So what is the inverse of a 2 by 2 matrix? So if you have matrix A, and if it is non-singular, and if it is a square matrix, so for the two conditions for the inverse of A to exist is that it must be non-singular, which means that its determinant, the determinant of A must not be equal to 0, and then it must be a square matrix, so basically an n by n matrix. The number of rows and the number of columns must be equal. If that is the case, then there exists an n by n matrix called A inverse. And it will also, the A inverse will also satisfy this particular property here. What this means is that the original matrix A multiplied by A inverse, or A inverse into the original matrix A, is equal to the identity matrix. And this is a 2 by 2 identity matrix. So if you multiply a 2 by 2 original matrix with its inverse, or the inverse multiplied with the original matrix, then it will give this 2 by 2 identity matrix. So the inverse of a matrix is found through this formula. The inverse of A is equal to the adjoint of A divided by the determinant of A. So to find A inverse, if A is this matrix here, so how will we find it? Simple. First off, you write down the formula so that you know what you're dealing with. And the second step is that you find the determinant of A. So the determinant of A is found like this. You multiply 5 and 1, and then you multiply 3 with 1, and then you subtract them like this. 5, 1, 3, 1, and then subtract them. And so 2 is the answer here. And then you will have to find the adjoint. So the adjoint of A is found like this. Now, the original matrix was this. What we've done here is that we've switched 5 and 1, and we've changed the signs of 1 and 3, and you get this matrix here. So this is the adjoint of A. So to find the inverse of A, you'll divide the adjoint of A with the determinant of A. And how you do that is basically simple. You'll divide each and every entry of the adjoint of A with 2. So 1 divided by 2, minus 3 divided by 2, minus 1 divided by 2, and 5 divided by 2. And that is the inverse of A.